Okay, guys, welcome to our live session. Hopefully, today we won't get any surprise load shedding sessions. Yesterday's lesson or yesterday's session or live session it's not uploaded onto YouTube yet, so but it will be soon, hopefully by the end of the day or tomorrow, depending on my schedule. I have to do a few things, but today we're going to focus on another Euclidean theorem. Yesterday we looked at one that said, I don't actually have that page here, that if there's a line coming from the center of the circle and it's perpendicular to the chord, then that line bisects that chord. But today's one is another Euclidean or circle geometry theorem that we're going to look at, which basically just states that the angle at the center, as you can see here, the angle at the center is twice the one at the circumference. Okay, so this is just a diagram, and this is just an example of how it can look, but it can come forth in many forms, and it can also look like this. But as you can see here, this is just an indication. Let me zoom in a little bit more. This is just an indication that the angle at the center, that's why there's two lines there, a quarter of a circle excuse me, the one is twice this one at the circumference. Okay, so that's just an example. Here's another example. So as you can see here, the angle at the center, so this angle here is twice that one there at the circumference. And here's another one, as you can see here, the one at the center is twice the one at the circumference. As you can see here, it's twice that one there. So if this one is 4, that one is 2. If this one is 6, then this one is 12. Okay, so we're just going to focus on 5 examples. You will never see me do these 5 examples again in a live session. Hopefully you'll see it somewhere on another platform of mine, but we're just going to look at 5 examples. So it might be a short live session, but we're just going to focus on that theorem. Okay, so the first one excuse me. So the first one looks at as follows. Okay, we are asked, by the way, for all the questions that we're doing, the from 1 till 5, all of the centers is going to be marked with O. Okay, marked with the letter O. So for instance, this example, center is at O. And now we are asked, what is the value of B? Okay, this angle here. So now, according to the theorem states that the angle at the center is twice the one at the circumference. So I'm going to write that down mathematically. So the angle at the center, which is B, is equal to twice the one at the circumference. So where's the one at the circumference? It's this one here. But I'm going to use the letters they've given us because I want to write down everything clear. So it's going to be the angle HJK, and that angle is, as we've seen, it is 45. So it's going to be 2 multiplied by 45 degrees, which is equal to 90 degrees. Okay, are we done? No. Okay, you will get 1 mark here, but now you're losing out on marks because you didn't include a reason whenever you do. So this is my I've got 5 steps that I've composed up in a playlist. You'll find it on my social media platforms. It's 5 steps on how to succeed in Euclidean geometry. And one of those steps is, whenever you do something, okay, write down the reason for that. So in this case, this is a very easy problem, okay? But when the questions get more complex, more complicated, then you'll see, okay, now I'm missing out on marks because I'm not adding my reasons. And whenever you do something, in this case, I'm saying this angle at the center is twice the one at the circumference. So that means I need to write that down mathematically. A short version of that is the angle at center is equal to twice the one angle at the circumference. Okay, so at circumference. Okay, there is your reason. You'll get a mark here. Now there's different notations for writing these ones. Some schools just, or some textbooks just, they don't write the full word. So depending on what textbook you're using. So it's very important to include your reason. So for those who have just joined us, just remember we're doing grade 11 Euclidean geometry. We're just focusing on the theorem that say the angle at the center is twice the one at the circumference. So if you have a friend that's in grade 12, or maybe this is part of the grade 10 syllabus, or they're in grade 11 doing this, share this live with them so that they can join us, and also double tap the screen because that will help a lot to get this session on the For You page. Okay, or if you have any questions, don't hesitate to ask. I usually do the example and then I run over it again. Okay, so here's our next one. We are asked now, what is the value of C? So the C here. Okay, and we are just focusing now. It's so easy, these problems, because not because I'm saying it's easy, because for a fact we're just focusing on one Euclidean theorem at a time. Okay, but in the exams they can just give it to you like this. They won't say it falls and you must use this theorem. You should know that you should use this theorem by looking at it. But for those who don't know, I have these steps in a playlist on my social media platforms. If you click on it, there's 5 steps on how to succeed in Euclidean geometry or circle geometry. Okay, let's get back to this problem. Here we are asked, what is the value of C? Okay, what is the value of C? So as you can see, it's different from the previous diagram, but it comes in many forms. Angle of the center is twice the one at the circumference. Angle of the center is twice the one at the circumference. Angle of the center is twice the one at the circumference. Okay, so here we have angle of the center is twice the one at the circumference. Okay, so we are asked what is that. So the angle at the center, which is JOH, so I'm going to write it down mathematically. So it's angle JOH. This angle here is equal to twice the one at the circumference, which is that angle CD. So what is angle JOH? It is this one here, which is 45 degrees, and it's equal to 2C. So that means my C is going to be equal to 22.5 degrees. Okay, am I done? No, I have to add my reason, and the reason is, so here you get 1 mark. The reason is, so as you can see, the more I write it, the better it will stick to my brain. Okay, so the reason is angle at center is equal to twice the angle at circumference. Okay, so there's my reason, and you will get another mark. So these are just the easy ones that we're going to deal with, but the more theorems we have in one problem, the more complex it will get. But my advice is always, as I've said, I've got a playlist, and one of those steps is focus on one theorem at a time. Yesterday we did one theorem. Today we're going to focus on this theorem. So now, in the next step of my steps on how to succeed in Euclidean geometry is to a problem which consists of those 2 theorems, and then you move on to the theorem number 3, and then you do problems based on those 3 theorems. That's all on one diagram or in one problem. Okay, so let's move on to the next. Well, let me first run through this one again. So here we are asked, what is the value of C here? Okay, so now how do I get C? C I get by telling myself, or one of the theorems states that the angle at the center is twice the one at the circumference. Okay, so what is the angle at the center? It is 45, but I'm going to write it down mathematically. So the angle at the center is GOH is equal to twice the one at the circumference. So I write it down mathematically, and now I'm just substituting, instead of writing this angle at the center, we saw it as 45 degrees, so there's it, is equal to 2c, and then I'm just solving c. I get my mark there, but I'm not done. I need to tell the person that's marking my stuff, why is it equal to, why did I do all of this? And the reason for that is the angle at the center is twice the one at the circumference. Okay, so let's move on to the next problem. For those who have just joined us, we are only focusing on 5 problems based on the theorem that states the angle at the center is twice the one at the circumference. So if you have any friend or family member that's in grade 12, let them know that we're only doing this today. Tag them in this post if possible, tag them in this live, or share this live with them. If you have a son or a daughter or cousin, let them know we are doing Euclidean geometry. Okay, so let's look at this one. Question 3. So as you can see, the previous examples look like this and like this, but now the next example is gonna, the previous one looked like this. The next example, we're gonna use this one here. Okay, so now remember, in all these problems, usually they will tell you in the question paper that the angle at the center is twice the one at the circumference. Okay, so here, they will say the center of the circle is O. So here we are asked, what is the value of D? Now remember, we can calculate D by saying the angle at the center is twice the one at the circumference. Okay, so let's write that down mathematically. So the angle at the center, which is D, is equal to twice the one at the circumference. So it's equal to twice the one at the circumference, which is hjk. So it's hjk. Okay, and what is that value? It is equal to 100. Okay, 100 degrees. So angle D is equal to 200 degrees. And what is my reason? My reason is angle at center is equal to twice the angle at the circumference. I keep on writing this forward, but it's not necessary. Okay, so let me quickly see if there's questions on the platforms on social media. If you have any questions, don't hesitate to ask. Now's your time to ask your questions, because we're going to get to more complex ones in the future. Okay, for those of you who are sharing the live or just join the live and sharing it, thank you very much. We are moving on to our second last problem, which is question 4. Now question 4, there is many solutions for this one, okay, but I'm just going to focus on the one. Just a warning for those who are, not a warning, but just a tip for those who have just joined us and you are doing this in school. Remember, math works like this in general. If you have hands and you have access to a pen or a book or a notepad or a pad or an iPad, whatever the pad is, take it out and do these calculations with me, because you need to write down something. It's not like a movie or series that you enjoy passively. This is need to do it actively. Okay, writing stuff down. Okay, so let's move on to the next question. The next question, there's many solutions as I've said, but I'm just going to focus on the one solution. And now remember, we've been focusing the whole time on this theorem. Okay, but this is like the second solution. The other solution is where you're going to use this theorem here. Okay, but remember, we can also use other theorems. Okay, this is now the one that we're currently busy with, and the other solution is where you can use it, but in this case I'm not going to use that. But if you want me to use this theorem in this solution, you can let me know. But The second solution will be a little bit longer. This one that I'm doing now is going to be a little bit shorter. Okay, so here we have a triangle, and we are asked now to determine the value of E. So what is given? It is given, we have this one. Okay, this angle here as 35. But there is a theorem that says that the angle in a semicircle is equal to 90 degrees. So this angle here is equal to 90 degrees. So I'm going to say angle JHK is equal to 90 degrees. And obviously, I can't just write it there. I need to write down a reason. So the reason is angle in semicircle is 90 degrees. Okay, you can just say angle in semicircle. Okay, so now I know that this one is 90 degrees. And what I'm going to do is, for the other solution, I'm not going to write it down, but I'm just going to tell you what it will look like. If you would like to know if yours is correct, you can DM it to me, or you can email it to me. I will try my best to check it out. Okay, but now if we have this here, okay, so this is 90 degrees, and we have this angle here, then we can actually find the value of E by using our grade 8, grade 9 knowledge that say, let's just write it down, triangle, because it's 4 triangles, triangle JHK, okay, E plus this angle here, so let me just write it down, JHK plus angle K is equal to 180 degrees. So there's a theorem that say angles in triangle, if we add it up, we get 180. Okay, so what is the value of E? We don't know. Just write it down. The value of JHK, which is JHK, we calculated that, or we determined it as 90 degrees, plus this angle here, which is 35 degrees, and it's equal to 180. And now we can obviously solve for E. If you solve for E, you'll get E as 55 degrees. And this is your reason. Okay, this should actually be here, but I just told you, okay. There. Okay, so let's see if there's any questions. This is our second last one. We will move on to the last one. So if you have any questions in connection with this theorem that said the angle at the center is twice the one at the circumference, let me know now, because we're going to move on to our next problem. But let's quickly look at this one again, and then I'm going to explain if you were going to use this theorem here with this problem. It's going to be a little bit longer than this one. Okay. Okay, so we were given E and 35, and the center of the circle, obviously O, and then they ask us what is the value of E. Then I said, okay, there's actually 2 solutions, but I'm only going to focus on the one solution. Okay, the second one I'm going to explain it to you now, but the first one is a little bit shorter than the second one. So the first one looks as follows. This angle is this angle plus that angle plus that angle equals to 180. Right, that's the idea that I'm going to use here. But I have this one, so if I can get this one, then I can calculate that one. Okay, but do I have this? Not this. Remember, this wasn't here. I just drew it here a few seconds ago. So this is 90. Okay, the reason for that is angle in a semicircle is equal to 90 degrees. So now I have this, and I can calculate this by using my grade 8, grade 9 theorem that say angles in a triangle adds up to 180. So this angle here plus this one plus that one equal to 180. Okay, then afterwards I substitute those values in there, and I get E, and the reason for that is, like I said, angles in a triangle adds up to 180. Okay, so let's move on to our last one. which is question number 5. And for those who have just joined us, we are busy with Euclidean geometry since yesterday was Tuesday, I think it was Monday. And today we focus on this theorem that states angle at the center is twice the one at the circumference. By the way, I forgot now to explain to you how I will do the second solution. I'm not going to write it down because it's going to be a little bit longer than this, but also I have to leave now in the next few minutes. Okay. So the second solution is, remember, we were given this angle and this angle, okay? And if you want to apply this theorem, then angle at the center is twice the one at the circumference. So if this is 35, then this one must be 70. So I'm going to use a different for solution 2. So that angle there is going to be 7. If this one is 35, this one is going to be 70. Okay, then you're going to say, obviously you can see that this is a isosceles triangle, which means this length is equal to that one. Okay, so if this one is E, this one must also be E. Then you can use the concept again of angles in a triangle is equal to 180. Then it's E plus E, which is 2E plus 70 is equal to 180, and then you solve for E from that point onwards. You will get exactly the same answer. So as you can see, we did use that theorem here. Okay, angle at the center is twice the one at the circumference. We have this, and then we just use our grade 8, 9, a theorem that say angles in a triangle. If we add it up, we get 180. Okay, so it's similar to this one, but now instead of using angle of the semicircle, we use this theorem. Okay, so let's move on to our last one. And this one is also quite easy. So for those who've been asking me yesterday also, I see it, the question did pop up now about if I offer extra lessons. It's only online, but you have to apply for that, okay? Because I need to see that you're serious about the lessons. I don't want to waste your time and money and my time as well. Okay, valuable time that we need now. Just maybe you want to do revision. Maybe you want to focus on this Euclidean, maybe the teacher didn't explain it properly, or maybe you need more information on that, okay, or other chapters, or maybe you want to focus on 2 chapters or 3 chapters. Please don't inbox me a day before your exams to squash and everything, because I'm gonna ignore it. I might reply, but yeah. So that's in connection with online lessons, and for that obviously you need access to internet. I use Zoom and I use WhatsApp, okay, at the same time. So let's look at this problem. This one is quite easy. So as you can see, we're still going to use this theorem, and we've been focusing on these type of problems and this one, and now we're going to have a look at, it's the same theorem that we're applying, okay? So with this one, so here obviously the center of the circle is O, and now we are asked what is the value of f, okay? What is the value of f? Now I'm going to make use of one of my theorems that say angle at the center is twice the one at the circumference, okay? So in other words, you can say, so just remember, we are given this angle here, okay? But the theorem says that angle there is equal to twice that one there. So we will first need to figure out what is this angle here, okay? And you're going to say that angle there is going to be it's going to be 360 degrees minus 120 degrees. And obviously, why am I doing that? So I'm just going to say an angle O, but you know what I mean if I write that, right? It's the, so this angle here is 360 minus that. Why am I doing that? It is because of revolution, okay? It is 360. So this angle here is going to be 360 minus that, it's going to be 240 degrees. Okay, but we're not looking for that angle there, we're looking for that one. So how do we get that one? We're going to use this theorem here. So the theorems say angle at the center, which is that one, so let's call that angle O, is equal to twice the one at the circumference, which is now f that we're actually looking for. What is the one at the at the center? It is 240 degrees, and to f, we solve for f, we get f, angle f is equal to 120 degrees. So the reason for that is angle at center is equal to twice the angle at the circumference. Okay, and that's my reason. I keep on writing. So you don't, like I said, you don't have to write the full word, just shorthand version. And just remember, there's many ways you can, various textbooks use various notation, but obviously the person that's marking your stuff will be able to, will obviously know what you mean. Okay, but don't write a whole paragraph. This is a one-line thing. This is one of those one-liners. Okay, so let's look at this problem one more time. We are asked what is the value of f. Okay, so, and it was given that this angle here is 120 degrees, and but now remember the theorem say the angle at the center is twice this one here, so we don't have that one, so we will first need to calculate that angle there. So how do we get that? By using revolution. Okay, just remember this is 360 all the way around. Okay, so how do we get that section? So it's going to be 360 minus 120. We solve this angle O there. Okay, so that O is equal to 240. Now we can say that this angle is twice the one at the circumference. So that means O is equal to 2f, and then we solve for f from this point onwards. So f is equal to 120. But you're going to get 1 mark, okay? Okay, obviously you're going to get another mark there, but you're going to get 1 mark, and you're going to lose out 2 marks if you don't write your reasons. So here's a reason and there's a reason. So this is like, I think, 4 marks worth. Okay, that's the end of our lesson here, where we focus on this theorem. Angle at the center is twice the one at the circumference.